we're focusing this chapter on all things related to lines, linear equations, lines. We'll start with kind of the very, very basics by graphing with just like plugging in points and making tables, and we'll move forward. You did a bunch of this last year. You spent a long, long time on this in pre-algebra. We'll spend a nice chunk of time today because it's that important. Being able to analyze a linear function is a very important task as far as building you up for later years. Tell whether something is a solution. Solution means if you plug in the point, it's on the line. You'll know a point is on the line by if you plug in the x and the y of our point, then you get a balanced equation. So if I plug in the x and the y into the x and the y in my equation, if it's balanced, it works, then yes, it is a solution. So I'll check this one. 4 goes for x. Plus 2 times the y, which is negative 1/2. And that's supposed to equal 5. Simplify the left side. Let's see. Parentheses, nothing inside parentheses. Exponents. Multiply. 2 times negative 1/2. What's 2 times negative 1/2? Negative 1. Positive times a negative is a negative. Half of 2 is 1. So is 4 plus negative 1 equal to 5?
It is not.
It is not. It's actually equal to 3. 3 is not the same as 5. So no, this is not a solution. How about the second one? Negative x plus 2y equals 8, and here's my xy. So minus x, or minus of whatever I plug in for x, plus 2 times whatever I plug in for y, is equal to 8. And what do you plug it in for x? Negative 2. And what do you plug it in for y? 3. 2. Minus negative 2. Positive 2. What's 2 times 3? Is 2 plus 6, 8?
Yeah.
Yes. The point negative 2, 3 is a solution to this equation.
I'll crash and burn. Wait, can we just turn around?
What if we have to graph? There's a lot of ways to graph equation lines. The most basic and the most fundamental, the way you can always fall back to if you forget everything else, is by making a table and plotting points. To do that, we want to start by, like we did in the warm-up, rewriting this equation. First, let's solve the equation for y. Let's rewrite this equation so it's a y equals equation. Well, what would you want? What do we want to do for this one to get y equals?
Subtract
2x. Let's subtract 2x from both sides. Once you solve for y, let's plot some points, or let's choose some x's and make a table. X is called an independent variable. Means we can choose whatever x's you want. So let's choose some x's that are easy to work with. I recommend choosing 0 and some small, both positive and negative values of x. Like easy numbers might be 1, 2. You also want to choose some numbers that are on the left side of the y-axis. You want to choose some negative x's too. So some easy negative numbers. How about negative 1 and negative 2? That'd be some good values. Notice I get to choose whatever x's I want because they're independent. I can't just pick y's though. I need to find y's. Well, if you choose x's, I could plug these x's into my equation and get y's. So like we did in the warm-up, let's do the following. Y y equals -2 times whatever x is plus 2. And we'll plug in these values of x and get some y's. So for instance, when x is 0, what's -2 times 0? What's 0 plus 2? 2. Okay, when x is 1, what's -2 times 1? -2. What's -2 plus 2? 0. How about when x is 2? -2 times 2? What's -4 plus 2? Okay, x is -1 this time. -2 times -1. +2 plus 2. -2 times -2. +4. +4 plus 2. Look at that, we have 5 points we can grab. Left and right 0, up 2. 0, up 2. Right 1, up 0. Right 2, down 2. Left 1, up 4. Left 1, up 4. Left 2, up 6. Left 2, up 6. Once you have those, I could have chosen any x. I did not what's called restrict the domain. I didn't tell you what the domain was, so you can pick whatever you want. So let's draw a line through those. And voila, straight line through those points.
Wait, how did you get that straight?
Let's try it again real quick. Let's first rewrite the second equation in terms of y. Solve the first equation for y. What needs to happen here to get this to be y equals?
Subtract 3x.
So this equation really should be y equals -3x minus 2, or -2 minus 3x. It's the same thing. I'm going to write it in sloping a step form. Then we'll make a table. Then we'll make a table of values. X's are the x's are independent variables, so you can pick whatever ones you want. How about you pick the nice, easy little ones? 0, 1, 2, -1, -2.
Why don't we just do
Again.
Why don't we just do 3x's?
Y equals -3 times something plus -2 or -2. And this something is what the x's we chose. So if I plug in 0, -3 times 0 is 0. 0 minus 2 is -2. And you can continue this game in your calculator. You don't need to show every single piece of work to do this. You can do this in your calculator. And you can use your calculator to calculate some more points. So if this is a 1 instead, that's a 1 instead. -3 times 1 is -3. Minus 2 is -5. -8. 1 and 4. You get more points by using your calculator, going quickly. Graphing this, left and right 0, up and down. Well, down -2. Right 1, down 5. Right 1, down 5. Right 2, down 8. Oh no, 8 goes off of my graph paper. So how about we just leave that one off for right now and see if we can still graph a line. We'll skip this one for a minute. Left 1, up 1. Left 1, up 1. Left 2, up 4. Left 2, up 4. We're still getting that nice line. If you wanted to sketch in, draw a couple boxes down to be able to get it, you could. Or you can just not. It's up to you. And draw yourself a straight line. Y equals -3. What this is saying, since there are no x's, that means that when I make a table of values, y is always -3, no matter what I choose for x. So if you had a table of values, y is always -3 no matter what x you choose. So pick a handful of x's. What are some values of x you'd like?
22.
Okay, let's try to restrict them to what I could graph. So like
0.
4, 0,
2.
1.
2.
Give me a couple negative numbers.
-2.
Negative 5.
17.
There we go.
4.5.
4, 0, 1, -2, and -5. Let's graph those points. Right 4, down 3. Right 4, down 3. Left and right, nothing, down 3. So 0, down 3. Over right 1, down 3. Back left 2, down 3. Right or left 5, 1, 2, oh, 1 too many, too far. Down 5. What kind of line is this making?
Great.
Okay, all lines are straight.
Oh, touche! That's pretty funny.
Okay, what? Give me a better name. What's a better name for this line? Horizontal is the name I'm thinking of.
People jumping on the table.
This is a horizontal line. A y equals line, no matter how you draw it, if it's just y and there's no x's, is a horizontal line through whatever point it tells you to. This one has to be through -3. So I want to take a stab in the dark at what an x equals line is going to look like. Vertical line. And you can prove that to yourself. If you just say, we did another quick table of values trick, x is now always 2. And y can be whatever you want it to be. 0, 3, -1, -4, +4. X is always 2. 0, 2, 0, 2, 3, 2, -1, 2, -4, 2, +4. X is always 2. That's a horizontal line. This gives us not perpendicular.
Vertical.
It's perpendicular to that horizontal line. It's a vertical line. That's supposed to be 3. I just picked it. You pick whatever x you want. I picked some x's that you can graph on that line. These have to be a vertical line. X equals equations are vertical lines through whatever value of x. Okay. We'll see how that affects the graph. And we'll quit after these two, so we won't do that finally. Graph this function, y equals half of x minus 1. But I'm going to tell you what x's you're allowed to plug in. You're only allowed to have a domain, or x's, that are less than or equal to 0. So if I'm graphing this with a table of values, let's pick some x's that you're allowed to use. I want 3 or 4 x's that we're allowed to use. Angela, what's 1?
Okay, 0.
Okay, we can pick 0 as allowed, because it's x is less than or equal to 0. Lily, what's another one we're allowed to use? -2 we could choose. What's another x value you're allowed to choose? Sure, we go -1. Let's stick with, how about like,
-4.
How about we just
we do -4, I'll do -6, I think we fit. Yeah, we fit -6.
Oh.
You keep going. In this specific instance, I think you'll notice that even numbers were nicer than odd numbers. So for these, let's find its partner y's. What's half of 0? 0 minus 1. -1. What's half of -2? -1. What's -1 minus 1? I'm using this formula and plugging in values of x. Half of -1. -1/2. What's -1/2 minus 1? negative 1.5, negative 3/2, negative 1.5. And what's half of negative 6? What's negative 3 minus 1?
No, negative what?
Negative 4. And let's plot these. Left and right 0, down 1. Left 2, down 2. Left 1, down 1.5. Do our best estimate. Left 6, down 4. And if you wanted to pick some other numbers, you could and plot them. The domain is x is less than 0. So where are all the x's? Just describe to me on this. Where are all the x's that are less than 0? Where are they located?
Oh, they're all.
What? Let me be more specific. What half of this graph has all the x's less than 0?
Isn't it?
Second and third quadrants, or the left half of this graph, of this piece of graph paper,
Only the third
have
one.
x's. So third quadrant has both negative x's and y's. Second quadrant has positive y's, negative x's. So what that means is, since I'm only graphing where x is less than 0, I'm only going to graph the line when it's in the left half of this graph. So I'll start here, and I'll graph my line in this direction. My graph starts here and goes on forever to the left, and it never goes past x is 0. It'll never be bigger than 0. So I have to stop my line when it gets to 0, because I restricted the domain. That means I can't go any farther. The number of pages a student types is given by this formula. Pages, or P, is equal to 4 times T, where T is the amount of hours spent typing. The student plans to type at most 2.5 hours. Graph this function and identify its domain and range. So we'll start with the graphing and we'll worry about the domain and range a little bit. If I want to graph it, I want to come up with a table of values. Or maybe better yet, T and P. Amount of time and the amount of pages typed. What are some possible amount of time you could spend typing in this situation? Lily, what's one possible amount of time? You could spend 1 hour typing, sure.
30 minutes. 2 hours.
If you typed 1 hour, how many pages would you get done?
4. Yeah, 4.
You get 4 pages done, okay? How about another amount of time you could type?
2.
You could type for 2 hours. And how many pages would you get done?
2.
Okay, what's another possible amount of time?
3.5.
I don't know.
What's the most amount of time you could possibly spend typing?
2.5.
So what if you did
1.5.
How many pages would you get typed if you typed for 2.5 hours?
9.
No.
Oh.
Don't guess. How would you calculate it exactly? 4 times 2.5.
Oh,
8 and
10.
1 up.
What is
2.5 times 4 is 10. What's the least amount of time you could possibly spend typing?
0.
You could just not spend any time. The least amount of time you can spend is 0. And how many pages would you get typed if you type for 0 hours?
No.
4 times 0 is 0. Look it, we have 4 points that we could plot from our function. X is 1, y is 4. Or t is 1, p is 4. T is 2, p is 8. T is 2.5, pages is 10. I spend 0 time typing, I get 0 pages out. And you could type for any increment in between there. As long as I start at 0 and I type anywhere for 2.5 hours, I could get anything that lies on this line would give me enough amount of pages I can get out. Would I want to extend this line farther? Why not? Why wouldn't I be able to extend this line any farther? Because I only type for 2.5 hours. So I can only plug in t's or x's that are up to 2.5. So I can't possibly have any points that are further along with bigger x's, because I can only type for 2.5 hours. What that implies is that we could be able to find what's called the domain and the range, where we can figure out what x's you're allowed to plug in. What x's are you allowed to plug in? What were the value? Where did x or where did t have to be between in this situation? What was the smallest amount of time you could type? 0. What's the most you could type? Okay, so the amount of time has to be somewhere between 0 and 2.5, and we'll represent in between with this compound inequality. We saw this a while back. 0 is less than t, so t is bigger than 0, but it's also less than 2.5. T is somewhere in between 0 and 2.5. How about the range? Before I get to the range, notice this. 0 and 2.5 corresponds to 0 to 2.5. That was all the possible x's I could graph. The range is the y's. So where does y start at? And where does it go up to? 10. So the range has to be, where is the number of pages in between? And 10. Domain and range.